Welcome back, and today we're going to look at the server directory of the Sidebar app. As you might have guessed, this is all the code that runs on the server, but unlike the modules directory, which actually also runs on the server, code that's here in the server directory will never run on the client. So typically you'll have your more Node.js oriented code, your cron jobs, your database related code, your little scripts, what have you. So although Vulkan apps are isomorphic, to use a fancy word, meaning they run both on the client and the server, and they share a lot of code, you will often have a big part of your code base be server only, just because there's so many things that the client doesn't really need to know about, or even shouldn't know about when it comes to payment processing, callbacks, background tasks. So today we'll go over this. So we have our entry point here, our main.js entry point into our server bundle. Just going to quickly go over the files here at the root of the directory. Sidebar has this little cache system using the node cache package, and this is just a way to invalidate. Well, it does two things. First, we define some callbacks to invalidate the cache. And here, all it says is whenever any model is created, updated, or deleted, we invalidate the cache. So for Sidebar, this works because it doesn't happen that often. Users will typically submit, let's say 10 links a day. So, and maybe I will work on the site moderating posts for 30 minutes in the morning. So overall, most of the time the cache isn't invalidated and it can do its job. Obviously, if users started submitting links all the time, then maybe we wouldn't do things this way and be a bit more granular about our cache invalidations. And the other thing this does is just serve a little dashboard, if you can call it that, just an endpoint that shows me stats about the cache. So this is provided by Node Cache, which has this built-in getStats function, and I'm just displaying that. What else do we have? This is a logging system that just intercepts every request to connect, which is what Meteor uses to serve the pages, the app. And then it logs that into a logs collection, just as a way to, to get an overview of what's going on in the app, see where the traffic is coming from. As you can see, there's like a setting here, just because it can be a lot of blogs, a lot of database documents. And so I usually disable logs unless I really want to get a snapshot. Cron, that's just how we run our cron jobs with Node cron. You might notice we use a lot of Node packages because everything that goes on the server is basically a Node app. There is some Meteor stuff in here, usually just to take care of Meteor's idiosyncrasies, but as much as possible, we just try to do things the regular Node way and kind of, let you do your thing with the tools that you're used to if you're coming from Node.js. Here we create some MongoDB indexes. There's some migrations helpers. You don't really need to worry about that. This is to force SSL. A few scripts. Yeah, also don't need to worry about that. That's because there was a previous version of Sidebar that had a different data format for something. So these are just migration scripts to kind of bring everything up to date. And here, this is also, well, this is what we use to trigger the migrations, mostly during local developments. That's why this is all commented out. Again, you don't really need to worry about that. What else do we have in these directories? This is where things get a little bit more fun. So again, we have index to centralize our imports. We have some cron jobs for posts. So this is where we define them. This checks for any scheduled post, meaning a post that's scheduled to run in the future but hasn't been published yet. And then if it finds one, it will update its status so that it becomes published. We have another collection.js file here for posts, and this one doesn't create the collection, but it extends it. So it extends it, meaning that we're creating a collection in modules, which also is available on the server, but then on the server only, we are extending it with additional things such as an API schema and callbacks. Now the API schema, as its name implies, is a schema that only lives on the server and only affects the API. So remember when I said that the other schema, the main one, was used for things like forms and validation and so on. And this one isn't. All it does is generate the corresponding GraphQL fields. And the consequence of that is these fields will never appear in your database, right? When you use at least the Vulcan mutations and the Vulcan default mutators, it will validate the document against the schema, which is the other schema, the one in modules, the main one. And these fields will never enter the picture, meaning there's no risk of having, a page URL or page path or URL redirect, whatever you want, in your database. Those will always be API only. And as such, they can also have like a simpler syntax. We don't need to define whether they're optional or not, what happens when they're created, because they're never created. They're read-only, API-only fields. Hopefully that made sense. If not, check out the Vulcan documentation. What else do we have here? We have some callbacks. So when a post is validated, check for duplicates. Duplicates, check whether it's scheduled. Before it's inserted, before it's created, get its Twitter metadata, set a discount amount, so that's for sponsored posts. And also when it's updated, send a payment notification. I won't go into too much details, but you can see how these callbacks work. And all these only apply on the server. Right, so these all concern the CRUD operations that are done on the server, so it makes sense not to define them on the client. We also have a REST API, or at least a JSON API, and this is where we generate it using Express. Again, we're not reinventing the wheel, we're just using common Node.js tools. One notable thing here is this run GraphQL function. This lets us execute a GraphQL query, but only on the server. So typically you have your client, the browser, basically execute some GraphQL query and get the result back from the server. Here we are, using the server to query the server. It's a bit weird because why not just hit the database directly since we're on the server? The reason for that is this way we can reuse the same fragments and the same basic data shape as on the client. So this helps a lot in keeping your app consistent and getting the benefits of GraphQL even when we're completely on the server, such as to generate this API or to generate the RSS feed. So what else do we have here? We have some GraphQL queries and mutations. So in Vulkan, most of your GraphQL queries and mutations will be generated automatically for you, but sometimes you need things that are a little bit more bespoke, more custom, such as these guys who these queries. So one will show you the available sponsorship dates based on yeah, based on the current time. So, you know, if someone wants to submit a sponsored post, I want to check whether next week is available or not. And this is how I do it. So it doesn't really return well, it returns an available date array, and available date is a type that I define here, which has a string and a date. So it's not directly related to posts, but because it's about sponsored posts, I grouped it here in the posts directory. The other one that we have is the Leaderboard Queries, which is you know, just a leaderboards field that returns a bunch of JSON. And the final one is the homepage. So this is interesting because the homepage is just regular posts, so we wouldn't typically need to create a new query resolver for it. But I wanted a way to really control the caching. So what this does is, instead of just well, hitting the posts resolver that is the default way to load posts, it's going to hit a homepage posts resolver that itself then executes a cached query against the GraphQL API and caches that data and returns it. So it's kind of a way to have this middle layer with a custom resolver as a way to really control the caching. Eventually, if we get a more elegant way to cache things, this might go away, but for now it works well enough. So that's it for posts. What else do we have? Newsletter is going to be following a very similar pattern. Lots of code to clean up. The newsletter, a lot of the newsletter stuff is actually defined in a Vulkan newsletter package, part of the core Vulkan codebase. Again, like I mentioned in a previous video about the payment stuff, this might get merged into the Sidebar codebase eventually. It kind of depends whether it makes sense to keep that as a separate package, or if I need to customize it to Sidebar itself, whether it makes more sense to bring it in and kind of have everything live under one roof. But for now, those mutations live over there, and I just import them and call that to actually add them and register them with the app. We have a few helpers here which do a bunch of stuff like getting metadata when someone submits a URL. So if I type in, I want to submit the sidebar.io link, this is going to scrape that page and kind of try to figure out the Twitter author, the title, the URL, things like that. And we also have some Twitter integration functions that currently get you the Twitter data of a user, so I can display their avatar. In the future, I also want to auto-tweet whenever a new link is submitted, so for now this isn't really used anywhere, but it might be soon. And then finally we get to the emails. So this is where we define our, well, emails. And let me switch back to the browser real quick and show you the development version of Sidebar. When in development, you have actually 2 extra dashboards. So maybe let me show you the database dashboard really quickly, because it can be useful. This is just a way to enter any document ID, any collection, any model, and load it from the database and show you the raw unfiltered data. So with GraphQL, often because you get a different document back than what is in the database, you can augment it, change it. Sometimes it's good to have that sanity check of, okay, what's actually in my database, what's the real data, and this lets you do that very easily. So of course you can do it with your Mongo shell or a Mongo desktop client, but this is often faster. And then to get back on track, the emails, here is the email dashboard. We are gonna take a post. Yeah, this one should work. So this is the link, join Medium. That's just any random link. I'll take a better one. Yeah, Lodash documentation. Okay, so this email just shows you a message with, you know, your link title, and if you click, you follow the link. So this is just what I show to people when they submit a link and it's approved. It's probably self-evident. And below you can see the test variables. And that's because this is a test, right? So there's not actually a request, a call to the send email or whatever function with arguments. So either to simulate that, you can explicitly pass variables in the URL, or it will just generate some random ID. So this is the variables we're testing with, and this is the data we get back to populate the email template. And this will make more sense in a minute. This is how we define emails. So we have this query. So we have two. We have one for posts and one for the newsletter, which is more complex. And then after that, we actually define the emails themselves. So an email has a template, a test path, which is what we just used to test it, a function to generate the to address based on the data. So here you can see, let me see. It's going to be data post result user email, data post result user. Here there's no email because this is test data, but in a real life scenario there would be an email here, and we're telling the email module to use that as the to address. Subject also gets data from the data object, in this case data post result title here, and then uses that. And then query is the query we saw earlier, which is a GraphQL query. And test variables is just a way to define the test variables right here. So to recap, because this probably doesn't make a ton of sense right now, but the way the Vulcan's email system works is, you define a GraphQL query that will get you all the data you need to send an email, whether it's the subject, the to address, the data used to populate the template. So that's step A. Step B, you feed that into a handlebar template. And step C, you send the whole thing. And that happens pretty much automatically. So it's really two steps. First, define the data, and then define the template, and maybe define a few helpers to kind of mash up the two. So the templates are right here, and you can see here I'm using, you know, the data again, post result URL, post result title, just accessing the same data object we have here. And that's why this debugging interface is so helpful, because it really lets you see exactly what the email is receiving and really figure out those paths easily. So that's it for the emails. There's a lot more documentation about this in the Vulcan docs. You can also look at the newsletter email, which is a bit more involved. The newsletter email is actually interesting because it's also used right here to actually generate the code and the data. So earlier I said step 3 is like merging the data and the template, and that happens when you send the email. But for newsletters, this actually happens when a newsletter document is created. And this is how we're able to preview the newsletter, get access to its code. So this email module can be used not just when actually sending email, but as a way to, let's say, pre-send them and preview them. And that's pretty cool because it just shows you the flexibility of this approach where it's, again, very declarative, where all the data comes from GraphQL and it gets input into that template. So that's it for the server. We have some other models, but they all follow the same pattern. So Hopefully by now you have a good understanding of at least what each file does in the modules and server directories, and we'll follow up next time with the components directory.